In this video lecture, we're going to learn about the principal quantum number, which is also in simpler terms called the shell number. And we're going to first revise what we studied in O levels. In O levels, if you had an atom, for example, if you had a sodium atom, sodium had electrons in shells. There were 2 electrons in the first shell, there were 8 electrons in the second shell, and there was 1 electron in the third shell. And the shells were numbered. There was shell 1, which was the one that was closest to the nucleus. Then you had shell 2, shell 3, shell 4. They were also referred to as the K shell, L shell, M shell, and N shell. So if I draw this on the diagram, this over here was your K shell. This was the one that was closest to the nucleus. And as you move further away from the nucleus, you had the L shell. Then you had the M shell and N shell, and etc. and so on. And we also discussed that if an electron is in shell number 1, then it has a very low energy. So that was the lowest energy shell. And as you moved away from the nucleus, so as the shells moved away from the nucleus, they had increasing energy. Shell L had more energy compared to K shell. Shell M had even more energy compared to the two shells above. Shell N had even more energy compared to the M, L, and K shells. So as you moved away from the nucleus, the energy of the electrons increased. But now when we talk about atomic structure, we're not basically looking at the atom like this. And we also know that the electron is not a stationary particle. It's defined by orbitals, areas where there's a high probability of finding an electron. So we can't really use this picture to describe what shell means. Now, what literally shell numbers would represent is it's going to represent the energy levels. So what I mean by that is, for example, if I have an s orbital, an s orbital would be a spherical region around the nucleus. So I'm going to draw an s orbital. There's a nucleus and there's an electron roaming around this nucleus, and that electron would be present in a spherical region around the nucleus, traveling very fast around this nucleus. So at any point we wouldn't be sure where that particular electron is, but it would be around in a spherical region around the nucleus, and this would be called an s orbital. Now the electron has low energy. So if an electron has low energy, what that would mean is that the electron would be attracted by the nucleus, and since it's not very energetic, so it's going to occupy a region that would be very close to the nucleus because it doesn't have much energy. So the electron would be attracted by the nucleus. So if the electron is having a very low energy, then it's going to be closer to the nucleus. It's going to be closer to the nucleus. Vice versa, if an electron has more energy, so I'm going to draw an energetic electron now. So if an electron has more energy, so let's try and draw an energetic electron. So this over here is my nucleus. Now if my electron has more energy, so the electron is now traveling, it's more energetic, so it's going to get further away from the nucleus because it can overcome the strong forces of attraction. So the electron is now occupying a much bigger, it can go further away from the nucleus because it's more energetic. So it's going to occupy a much larger area compared to the previous case. So that electron traveling very fast around the nucleus, to an outside observer it would appear that the electron is everywhere in this region. But since the electron is now more energetic, so that would mean that it can overcome the strong forces of attraction. The nucleus is trying to attract this electron, but the electron is now more energetic, so it can fly around and occupy a much larger area. So vice versa, if an electron has high energy, now that indicates that the electron is going to be further from the nucleus. So since orbitals were regions defining where the electron has a higher probability of occupying, so if there's an s orbital and the electron has very low energy, the s orbital would be much smaller in size, because now the probability of finding an electron is in a much smaller space because the electron is closer to the nucleus, it's less energetic. But if the electron has more energy, that means the electron could go further away from the nucleus, it can overcome the forces of attraction of the nucleus, and it goes further from the nucleus. So the electron is occupying a much larger area. So another thing that we can come up with is that if an electron has low energy and it's going to be present in an orbital, it would be present in an orbital. So the orbital would be much smaller in size. So there's going to be a smaller region, a smaller orbital. They would be occupying a much smaller orbital. And if an electron has high energy, that would mean that the orbital is much bigger. So it's going to be occupying a much bigger area. So the orbital would be much bigger in this case. So now when you think of shells, don't think of this image. This image is incorrect. It's a simplification. When you think of shells, if an electron is in shell 1, that would mean if it has a principal quantum number that is 1, then that would mean it has low energy. If it's in shell 2, that means it has higher energy. It would be further away from the nucleus. If it's in shell 4, that would mean it's even further away from the nucleus. So you're going to imagine orbitals. When you think of shells, imagine orbitals. If an orbital is in shell 1, that means it has very low energy and the electron would be close to the nucleus. So this is called a 1s orbital. What this 1 stands for is the shell number. So each orbital would have a shell number attached to it. So 1s means that it's in the first shell. So this over here means that it's in the first shell. So if an electron is in the first shell, that would mean a spherical region around the nucleus, but very close to the nucleus because the electron is not very energetic. Similarly, if an electron is in a 2s orbital, again this 2 stands for that it's in the second shell. So since it's in the second shell, that would indicate that the electron in the s orbital is more energetic and it would occupy a much larger spherical region around the nucleus, and so on and so forth. Now I've drawn 3 s orbitals. The s orbital is a spherical region around the nucleus. The center part is the nucleus. So there are 3 s orbitals. This one is the 1s orbital. 1s means that it's the orbital is in shell 1, which means that it is the lowest energy. So the electron is occupying a region that is closest to the nucleus. So this is the low energy orbital. So the electron is lying very close to the nucleus. Now if the electron gets energetic and it is now part of the second shell, so I'm going to call this the 2s orbital, where 2 stands for the shell number. So the electron is now more energetic and it's occupying a much larger area. So the energetic electron can overcome the force of attraction. It's occupying a much larger area. Similarly, this is the 3s orbital, which means that the electron is now in the third shell. It's even more energetic. So the probability of finding an electron is now further away from the nucleus. So the orbital size keeps on increasing as the shells increase. So as you move to the right in this diagram, the energy of the electron is increasing. So there's more and more energy. So the electron is going to occupy a much bigger area. Same goes for the p orbital. So I'm going to show you the same thing with the p orbital. P orbitals had 2 lobes. They were double shaped. So the electron density was lying on either side of the nucleus. So if the electron is in the 2p orbital, that's a low energy orbital. So the electron is very close to the nucleus. If the electron is in the 3p orbital, 3 stands for the third shell. So if the p orbital is in the third shell, that indicates the electron is now more energetic and it's occupying a much larger area. It can move further away from the nucleus. If it's in the 4p orbital, that indicates that the electron is even more energetic. So it's going much further away from the nucleus. It's becoming more and more energetic. So remember this, that the shell number tells you the energy of the electron. So if the electron is energetic, it's going to be further away from the nucleus. If it's not energetic, then it would be close to the nucleus.